In this video, we are going to talk about a new type of transformation called a dilation. And dilation, okay, so here are all of the points in the pre-image on the left, and here are all of the coordinate points for the image on the right. So if you look at every single number in the pre-image, it's been cut in half for the coordinates on the image. And that's what the dilation of 1/2 told us to do. So now we're going to go and graph the pre-image and the image. So the pre-image, point P was -2, 4. Point P prime, I'll do P prime next. Q is 4, 4. R is 4, -2, and S was -4, -4. So connecting my vertices gives me a quadrilateral PQRS that looks like this. So now let's go and graph the image. P prime is -1, 2. Q prime is 2, 2. R prime is 2, -1. And S prime is -2, -2. So connecting again the vertices gives me my image, and as we already knew, this was going to be a reduction, so my image, my new quadrilateral, is smaller than the original. So moving down to part B, the question asks us to demonstrate that these quadrilaterals are similar by comparing the ratios of their lengths. So I'm actually going to compare side PQ to PQ prime using the ratio of the notes up above. Remember, when we had a ratio, it's the image length divided by the pre-image length. So the image length would be PQ, and then the image length would be P prime Q prime divided by the pre-image, which is PQ. So the length of P prime Q prime is 1, 2, 3, and the length of PQ in the pre-image is 1, 2, 3, 4, 5, 6. And I'm able just to count how many boxes because those are horizontal lines that lie directly on the coordinate plane. So 3/6 reduces to 1/2. And let's just check one more corresponding side to make sure that the ratio holds true. Let's compare Q prime R prime to QR. So Q prime R prime is 3. Again, I'm just counting the lines because it's a vertical line here. 1, 2, 3. And QR is 1, 2, 3, 4, 5, 6. So again, the ratio of the two sides is 1/2. So part C wants us to look at the angle measurements of the two figures. If you look at the angle measurements of the two figures, you'll notice that, especially also with similar shapes, the angle measures don't change. It's only the lengths of their sides. So the angle measurements of the two figures, we would say that the angle measurements are the same. And remember, the word for the same is congruent. Now, this says, last question here, is the resulting figure similar or congruent to the original figure? Now we're actually talking about the entire figure itself. Well, if you look at the image, P prime, Q prime, R prime, S prime, it is smaller than the original quadrilateral, but it's still the same shape. It's just not the same size. So to answer this question, the resulting figure is similar. And the reason is because it is the same shape, but a different size. The only thing that stayed congruent when we did a dilation was the angles. Okay, in example 5, they give us quadrilateral A prime, B prime, C prime, D prime, and they tell us that it's a dilation of quadrilateral ABCD. In this example, we're not given the scale factor. We have to find it. So we need to classify the dilation as an enlargement or a reduction. So First, I'd like to point out that quadrilateral ABCD is this one, and quadrilateral A prime, B prime, C prime, D prime is this one in here. So we can already tell that this dilation is probably going to be a reduction because the image is smaller than the pre-image. We just don't know what the rule is. So the rule is x comma y, arrow, and then we just don't know what goes inside our parentheses. So that's for us to find out. One way we can find out is by looking at the coordinates from the pre-image and the image. So we can compare the coordinates from the pre-image and compare that to the image. So let's list the points in the pre-image. For point A, the coordinates are 6, 0. For point B, the coordinates are 0, 6. Point C is -6, 0, and point D is 0, -6. When we perform the dilation, the coordinates of the image for point A are now 2, 0. That's A prime. B prime is now 0, 2. C prime is now -2, 0. And D prime becomes 0, -2. So notice that the zeros stay the same, but that makes sense because whenever you perform a dilation, when you multiply anything by 0, it stays 0. So I would encourage you to look at the numbers. We went from 6 to 2 for point A to A prime. We went from 6 to 2 again for point B to B prime. We went from -6 to -2 in C to C prime, and again -6 to -2 from D to D prime. So it looks like what's happening is we're taking the coordinate points in our pre-image and we're dividing them by 3. Dividing by 3. So the scale factor R is going to be 1/3. Multiplying by 1/3 is the same thing as dividing by 3. So our rule is going to be take our x and y coordinate points and multiply the x by 1/3 and multiply the y by 1/3. And again, that's the same thing as dividing all of the coordinates by 3. So we came up with the rule and we found the scale factor by looking at the coordinates of the pre-image and the image. I will save example 6 for you to do on your own. When you have finished example 6, compare with your group mates or call Ms. Penikitis over to check your work.